Welcome, everybody. My name is Suresh Srinivasan. I'm the coordinator of the Minnesota Astronomical Society's Beginner Special Interest Group. I'm excited today to have Dave Falkner, our esteemed Dave. What are you now? Are you still secretary? No, that's Claire.
No,
Are you?
that's clear. No, I'm just
I
I'm just a
forget.
regular member now.
You're just a regular guy. I'm excited to hear Dave's talk today on the Dragonfly mission and Titan in general. Dave, I'll just read your quick biography, Dave. He's a
Okay.
lifelong amateur astronomer. He became interested in astronomy as a teenager, or maybe even as a preteen, growing up in Indianapolis. He was in the Navy for I think 20 years,
20
and
years, yep.
then moved here to Minneapolis and became active in the MAS. He's been president twice, it looks like, 2011 to 2014, and also 2019 to 2020, and then was secretary from 2023 through 24. And he's also active in our club's outreach program, and he's a NASA Solar System ambassador. So I'm looking forward to this talk. I'll turn it over to you, Dave.
Well, thanks a lot, sir. I appreciate the introduction. Let me tell you a little bit about the Solar System Ambassador Program. That's a group of people who are volunteers for NASA. We're not paid by NASA. There's I think, about 1,200 of us nationwide and a few internationally. And we go around and speak to the general public about space exploration, and NASA missions in particular. And today we're going to talk about Dragonfly as well as a couple of other NASA missions. I'm going to start by talking about the discovery of Titan and ground-based telescopic observations that were made. And then we'll talk about what we learned from previous NASA missions that flew by and landed on Titan, actually. We'll
Hey,
talk a
Dave,
little bit about NASA's. Yeah,
can I just
what?
two housekeeping things before you get going? This meeting's being recorded. And if you have a question for Dave, click on the chat button on the bottom of your screen. And when he comes up for air or pauses, I will ask the question for you. That way he keeps his rhythm and, we keep moving forward. So if anybody has any questions on that, just let me know and we'll work on it. All right, Dave, back to you.
Sounds good. And then after we talk about some of the previous NASA missions, we'll talk a little bit about NASA's experience with autonomous drone technology. And then we'll talk about the Dragonfly mission in particular. I will stop from time to time for questions. So as Suresh said, just put your question in there or say that you have a question. And when I stop, we can address those. So Titan was originally discovered by the Dutch astronomer Christian Huygens, March 25th, 1655. And it was the first moon outside of our own that was discovered since the Galilean moons were discovered in 1610 by Galileo. He named the moon Saturne Luna, or Moon of Saturn, okay, which was great until 1847 when John Herschel discovered two more moons around Titan, Mimas and Enceladus. That's what the name he gave those, and so he gave that original moon name Titan. Okay, so until recently, the moons around Saturn were all named after the race of mythical giants, and Titan is the name for the race of immortals in Greek mythology. Now, in more recent years, the International Astronomical Union has expanded their naming convention to include other mythologies. And so some of the more recent moons that have been discovered around Saturn have been named after Norse mythology, for one. So astronomers were able to find a few things about Titan from their observations. They were able to note that, Titan orbited Saturn about once every 15.94 or 16 days, roughly. They couldn't see the surface of Titan, and so the rotational period originally was unknown on that. Its max apparent magnitude is 8.2, so it's pretty easy to spot even with small telescopes. You can see Titan. Its distance from Saturn, about 20 Saturn radii, or about 1.2 million kilometers. It has a yellowish color, but no discernible features, as I said. Telescopically, it appeared larger than Ganymede. So for a long time, Titan was considered the largest moon in the solar system. Since then, we discovered there's actually an atmosphere, and so the Titan, the moon itself is actually slightly smaller than Ganymede. But both moons are larger than Mercury. We'll see that in just a second. The presence of a significant atmosphere was first made in 1903 by the Spanish astronomer Joseph Comas y Sola, who noticed limb darkening, which is a phenomenon that you have when there's an atmosphere around a planet. Otherwise, it's a sharp daytime to nighttime transition across a terminator line. But later in 1944, an atmosphere was confirmed by Gerald Kuiper using spectroscopic techniques. And he observed that it was primarily nitrogen with some methane, although he grossly underestimated the amount of methane in the atmosphere. And he also wasn't able to really accurately determine the surface pressure of the atmosphere. So detailed atmospheric observations really weren't made until the Voyager 1 spacecraft flew by. So if we take a look here on the left, we see comparative sizes of some of the larger moons. And with the atmosphere, Titan does appear to be slightly larger than Ganymede. But on the right, we show the actual sizes of the moons. And we can see that Ganymede is a little bit bigger than Titan, and they're both bigger than Mercury. In addition, we should note that Titan's about 50% larger than Earth's moon. So I'm going to pause here. Is there any questions to this point?
I don't see any questions in the chat.
Okay, we'll move on then. Beginning in the 1970s, NASA began exploring the outer planets of the solar system using robotic spacecraft. And Pioneer 10 and 11 were launched in the early 1970s, and Voyager 1 and 2 were launched later in the 1970s. Pioneer 10 flew by Jupiter, but did not fly by Saturn. Pioneer 11 flew by Jupiter and Saturn. And it was launched in 73, and then flew by Titan and Saturn in September of 79, and then we lost contact in November of 1995. And then Voyager 1 was part of the Grand Tour mission. I'll talk a little more about that in a minute. Launched in September 5th, 1977, and did the Saturn Titan flyby in November of 1980. You may want to note that that's only a little over a year after Pioneer 11 flew by, and we'll talk about that in a minute too. Currently, Voyager 1 is 15.6 billion miles from Earth and is still operational, amazingly. So Pioneer 11 was the first spacecraft to encounter Saturn. Its goal was to explore Saturn and the environment around Saturn. It obtained what was called spin scan images of the Saturnian system in two colors during its encounter. And it was able to determine more precisely the mass of Saturn and the larger moons by accurately observing the effects of their gravitational pull on the spacecraft. The images of Titan's atmosphere indicated that it was substantial and complex and worth further investigation. You can see this is an image from Pioneer 11. It also indicated that the images and measurements from Titan concluded the moon was too cold to support.
It's a little tight. I wonder if I should try to move the.
If you're
Doug,
if you can mute, I'd appreciate it.
Yeah, Doug Munson, can you mute your computer?
There we go. Okay. So in the late 1964, NASA realized that in the late 1970s and early 1980s, the outer planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, would be on the same side of the sun and kind of in alignment. It was a unique alignment that only occurred every 175 years. But that alignment would allow a spacecraft to use a maneuver called gravitational assist to propel it from one planet to the other without using any additional fuel other than for maneuvering purposes. So they created a mission called the Grand Tour that was supposed to have spacecraft fly by Jupiter, Saturn, Uranus, and Neptune, and actually Pluto originally. And the Voyager spacecraft were launched in 1977 with this in mind. Okay. About the same time in 1979 that Voyager 1 was making its flyby of Jupiter, Pioneer 11 was executing its flyby of Saturn. And originally, Voyager 1 was going to fly by Saturn and then proceed on to Pluto. But the images from Pioneer 11 intrigued NASA scientists enough that they decided to change Voyager 1's trajectory so that it would make a close flyby of Titan instead. And this new trajectory meant that Voyager would no longer be able to go to Pluto. However, Voyager 2 would fly along its original trajectory through the rings of Saturn and then continue on to be the only spacecraft to visit Uranus and Neptune. Okay. So what you see here is a diagram of the trajectory of Voyager 1 as it passed through the Saturnian system. And you can see it passed right by Titan on the right there first, and Mimas and Enceladus and Tethys, and then finally Rhea at the other side. It passed within 4,000 miles of Titan, so which is relatively close. Voyager encountered Titan on November 11th, 1980, and discovered that the mass of Titan is about twice that of the Moon. It also detected a substantial atmosphere and was perhaps denser than Earth's, and it turns out that it is actually denser by about 50%. Scientists measured the atmosphere's effect on sunlight, and Earth-based measurement of its effect on the probe's radio signal were used to determine the atmosphere's composition, density, and pressure. The thick haze, though, prevented any observations of the surface, and Voyager 1 didn't have the camera equipment or technology to do that. The atmosphere of Titan was the surface pressure is about 50% higher than Earth's. Its surface temperature is minus 273 degrees Fahrenheit, so it's pretty brisk. Primary components, nitrogen at 94%, methane about 5.65%, and then hydrogen at 0.99%. There are also trace amounts of other hydrocarbons, and you can see the list of them there. The orange color is produced by the more complex chemicals in small quantities, while the blue upper atmosphere is caused by the byproducts that form the compounds like ethane and acetylene, and that they're created by the ultraviolet sunlight coming through and breaking up the methane molecules, and that tends to scatter blue and ultraviolet light. So that's why the very upper atmosphere looks kind of bluish. The orange color is the organic precipitate, and they're called tholins collectively. So that's what causes that orange color. That all this is very interesting to scientists because the fact that you have hydrocarbons in the atmosphere, these are kind of the building blocks of life, and so it was very, very interesting for them, and was compelling to launch a couple of more missions. Let me stop here. Are there any questions about Pioneer and Voyager?
I don't see any comments in the chat, but I will say, Dave, I will add to your comment about the color of Titan that any telescope, at least I'll say 4 inches and above, will show the color of Titan. Despite the 900 million mile distance, you can see this through your telescopes, this atmosphere.
Yeah. Okay. Very cool. All right. The discoveries of Pioneer and Voyager flybys motivated NASA to prepare a mission dedicated solely to investigating the Saturnian system. And Cassini-Huygens was a joint NASA ESA mission at the European Space Agency mission, launched October 15th, 1997, and arrived at Saturn on July 1st, 2004, for a 3-year mission to explore the Saturnian system. The end of mission was 13 years later, so really overperformed there. On September 15th, 2017, when they basically Cassini ran out of fuel and they wouldn't be able to control it. And they didn't want it to just contaminate the surface of one of the moons. So they deliberately directed it into the atmosphere of Saturn so that it would burn up in the atmosphere. Cassini made over 45 passes by Titan. It had special imaging filters that were able to penetrate through the global haze, and it revealed methane clouds near the South Pole. The surface was imaged by radar and revealed it was fairly level with some hills reaching a few hundred feet in altitude. It was also able to detect lakes of methane on the surface. And it determined that, like our moon, Titan is tidally locked with Saturn. So the same side of Titan always faces Saturn as it orbits around it. The Huygens lander was provided by the European Space Agency, and it separated in December of 25th, 2004, and landed on Titan on January 14th. It was designed to have 3 hours of battery life, most of which would be used as it went through the atmosphere. It was primarily designed to gather data about the atmosphere. So engineers expected about 30 minutes of data at most from the surface. When the mission was planned, it was not yet certain whether the landing would be at a mountain range, a flat plain, an ocean, or something else. The final landing site was determined by analyzing the data from the Cassini spacecraft during several flybys it made prior to releasing Huygens. And Huygens touched down on land, although the possibility that it could touch down on an ocean was also considered in its design. The probe was designed to gather data for a few hours as it descended through the atmosphere and possibly a few minutes at the surface. It continued to send data for about 90 minutes after it touched down on the surface. The surface was found to be kind of a sand, if you would, of ice grains and ice pebbles coated with hydrocarbons. And they confirmed the temperature at the landing site was about 94 Kelvin or minus 291 degrees Fahrenheit. Huygens had 6 instruments that were primarily for collecting atmospheric data as it descended to the surface. They had this Huygens atmospheric structure instrument, measured temperature, pressure, wind gusts, electromagnetic activity, kind of the physical and electrical properties of Titan. The Doppler wind experiment detected radial velocity and drift. The descent imager and spectral radiometer measured radiation balance inside the atmosphere as the spacecraft descended to study the effects of sunlight and solar heating on the atmosphere. The gas chromatograph and the mass spectrometer were used to identify and measure the chemicals in Titan's atmosphere. And then the aerosol collector and pyrolyzer was used to actually extract aerosols from the atmosphere, heat them, vaporize the volatile, and decompose the complex organic materials, and then analyze them. And then once it hit the surface, it had a surface science package that contained a number of sensors designed to determine the physical properties of Titan's surface at the point of impact and whether the surface was solid or liquid. So as I mentioned, Huygens was primarily a mission to analyze the atmosphere, and Huygens was in the atmosphere for about 2.5 hours as it floated down. It's a thick atmosphere and low gravity that the parachute really slowed it down quite a bit, so it was able to spend a lot of time in the atmosphere. And it found that the primary constituents, as we kind of already knew, was nitrogen, methane, and a little bit of hydrogen, and there were trace amounts of many other hydrocarbons. So the precise atmospheric composition varied, though, depending on the altitude and the latitude, due to methane cycling between a gas and a liquid in Titan's lower atmosphere. We'll talk about that in a little bit. It's called the methane cycle. Probably, again, not surprisingly, that the concentrations vary with altitude, but methane concentrations were highest near the surface. Methane is a very heavy gas, and so it would naturally gather more at the surface of the planet. There are also trace amounts of many other hydrocarbons thought to form in the upper atmosphere from the breakup of methane by the sun's UV rays. We kind of talked about that already. Okay. So when you're talking about the methane cycle, so on the Earth, we have what's called the hydrologic cycle. And it's the cycle of water vapor, right? Water vapor evaporates from lakes and rivers and oceans and goes up, eventually condenses into clouds, and then will precipitate back down as rain or snow, and then again gather in lakes and oceans and rivers and evaporate again, and so on and so forth. And that's the hydrologic cycle. Titan had a similar cycle, but it was with methane because it's so cold. So the methane would evaporate and go into the air. There were lakes of methane and ethane. So they would be predominantly across the polar regions. The methane would condense into clouds in the atmosphere and then precipitate back onto the surface where it flowed back to these lakes and the like. And so it was just kept that cycle going. Um, there is some methane that's lost in this cycle, and they think that there's a couple of ways that it could be replenished. One is that some of the methane could have been captured during its formation, was under the surface, but through cryovolcanoes, which are volcanoes, but instead of spewing lava and silicon dioxide, they actually or sulfur dioxide rather sulfur dioxide they spew nitrogen and methane, and it would come back into the atmosphere that way. Another theory is that methane could have formed and been surrounded by ice crystals, a process called methane clathrates. And when the clathrate coating eventually disassociates from the methane, then the methane is released into the atmosphere. So that's just a couple of ways that the methane can be replenished. Titan's surface, again, it was imaged and also by using radar from Cassini. And when Huygens hit the surface, they found that it was largely featureless. Okay, there were some small pebbles. The image on the left there shows these pebbles on the ground. Those are very small, though, just a few centimeters in diameter. So it's described as sand made of ice grains or snow that has been frozen on top, and then the pebbles are believed to be hydrocarbon coated water ice. And then and we think that Huygens probably landed in a dry lake bed. So as I mentioned, when it landed, they thought it only had about 30 minutes remaining of its battery power, but it lasted longer than that. It landed near a dark sea region on Titan, and there's evidence of liquid acting on the surface, suggesting flows of liquid hydrocarbons to the more permanent lakes located in the polar regions. So they felt it kind of landed. It was basically a dry lake bed. Scientists realized that the limited findings from the Cassini-Huygens mission clearly warranted a closer look at a dedicated spacecraft, particularly one that would be able to analyze more of the surface of Titan. Okay, I'll pause here real quick. Any questions about the Cassini-Huygens mission?
Yeah. Does somebody have a question for Dave? Dave, I do have a comment. If you go back one
Sure, go ahead.
slide, just to add on to what you said. So one thing between Earth and Titan, you notice Dave's got 50 kilometers at the top for the Earth. The acknowledged boundary where space begins is 100 kilometers. It's called the Kármán line. Look on Titan. Look how much higher the atmosphere goes. It's a much the atmosphere extends so much higher off the surface from Titan. To Dave's point earlier, when back in the day they thought that Titan might be larger than Ganymede, it was because the atmosphere was fooling them. They weren't sure where the atmosphere ended and the moon actually, the rock of the moon actually began. But you see how much higher up the atmosphere of Titan is versus the Earth.
Yeah, for sure.
Dave,
Okay.
I do have a question. Paul has a question. Are there any
Oh, yeah.
volcanoes on Titan? Paul
Well,
Gaines
the
asking.
cryovolcanoes, and I don't know. I think that the imaging has shown that there's evidence of those. I don't know if they're active or not. Okay, but uh, several moons in the solar system have cryovolcanic action. I know that Triton does too, and a couple others, where the volcano is spewing nitrogen primarily, and in this case, some methane.
Great. Any other questions for Dave? All right, back to you, Dave.
All right. Well, I'd be remiss if I didn't talk about Ingenuity, which is the Mars helicopter. Ginny, as it is affectionately known, was the first extraterrestrial helicopter. Its primary mission was mainly a technology demonstration that an autonomous helicopter could operate on Mars. If successful, it was thought Ginny could perform reconnaissance flights for Perseverance, which was the primary spacecraft that it rode on getting to Mars and working on Mars. Okay, this is kind of a image of Jenny and the various components of it. It was developed. The development and testing of the helicopter began in 2012. To reduce the cost, it used off-the-shelf components to build it, and then underwent extensive testing in simulated Martian environments. They were able to reproduce an atmospheric pressure of about 0.6 of Earth's, which would be the equivalent of going up to about 112,000 feet. They were able to test it with in a gravity that was 38% of Earth, and then temperature ranges from 32 to minus 70 degrees Fahrenheit to simulate the Martian environment. They realized that with the Martian atmosphere is quite thin, really, and so the blades would need to rotate at about 2,400 RPM to provide enough lift to maneuver. So these two sets of blades, and they were counter rotating so that you could keep stability for the payload that was hanging underneath it. Because the helicopter could not be operated in real time, autonomous instructions were uploaded for each flight. There's about a 7-minute delay between Earth and a transmission from Earth reaching Mars. It takes about 7 minutes. So there's no way that they could fly it real time. The Mars Helicopter Scout was the original name of that, but it was renamed Ingenuity through a NASA essay contest called Name the Rover. And in April of 2020, it was renamed Ingenuity by Vanessa Rupani, who's an 11th grade girl from the Tuscaloosa County High School in Northport, Alabama. NASA did that quite often, to name the rover type thing, to have the public get involved and kind of get the public interest as well as educated about the rovers and what they were doing. So Ingenuity, as I said, rode with Perseverance to Mars. As late as 2019, however, Ingenuity was neither included nor budgeted for the Mars 2020 Perseverance mission. The NASA scientists and leaders actually opposed of including Ingenuity as part of the Mars 2020 mission. Despite the assurances that the helicopter would outpace the rover and provide valuable scouting information, the chief scientist, Kenneth Farley, thought Ingenuity would impact the science schedule, and its ability to outpace the rover would be countered by the improved auto navigation system that was included with Perseverance. However, in the end they did include Ingenuity with the mission, and it was deployed from Perseverance on February 18th of 2021. The helicopter did keep up with Perseverance until the spring of 2022, when it began to fall behind due to insufficient solar energy during the Martian winter. As I mentioned, it was originally a technology demonstration. Its goals were just to perform 5 flights in 30 sols, which is roughly a Martian month, fly up to about 90 seconds, attain an altitude of 10 to 16 feet, and then travel up to 160 feet downrange, return, and land where it started. And it would take black and white and color images of the Martian surface. Okay. Well, after about 3 flights, they realized that the helicopter was performing well beyond its original expectations. And so they were given the go-ahead to change the goals. Okay. So now it became an operational demonstration. And for that, the main goals were to avoid significant interference with or delay of rover operations, maintain the vehicle health and safety, and perform scouting for tactical and planning and science assessment, perform the experiments to inform the mission and the vehicle design for future Mars rotorcraft, or collect data for discretionary science. In the end, Ingenuity took 72 flights, okay, and flew up to 79 feet in altitude. It flew for over 128 minutes total, lasted for over 2 years, and flew about 11 miles. So, and it was obviously the first helicopter on another planet. Flight 72 was the infamous flight, and it was flying in a very um, featureless area. It was sand dunes and the like. And they think that the auto navigation system may have gotten a little confused as a result of that. And one of the blades hit the ground and broke off. And so you can see in this image of Ingenuity after the accident where one of the blades is broken off. The other one you really can't see, but it's badly damaged. So it clearly won't be able to fly anymore. And so they repurposed it into a stationary science laboratory, so to speak, and it would continue collecting data about the weather in the area, weather data, and it could do that for 20 years. And then some future rover or some future spacecraft would be able to download that data so they could see what the weather was like as it was just sitting there on the surface of Mars. Okay. Any questions about Ingenuity?
I don't see any questions in the chat. Does anybody have a question for Dave on this?
Okay, well,
All right,
let's
Dave,
move
back
on.
to you. Okay.
You bet. So let's talk about Dragonfly. Okay, the success of Ingenuity and the autonomous rovers on Mars were the inspiration for this mission. Dragonfly is an autonomous 8-prop rotorcraft, or drone, if you would, for exploring Titan. While Ingenuity was a technology proof of concept, Dragonfly is the first mission designed to explore an extraterrestrial world with this kind of spacecraft. It is a 3.3-year mission, and during that time, Dragonfly's rotors will carry it up to 70 miles across Titan, stopping to explore a variety of geologically interesting areas along the way, including dunes and the Salk crater. I'll talk a little bit more about that in a minute. Why send Dragonfly to Titan? Well, as we've already talked about, it's kind of a unique moon. It's the only moon in our solar system with a dense atmosphere and low gravity. And Titan and Earth atmospheres are both predominantly nitrogen. And organic chemistry is happening on Titan in a unique way. Although Titan has notable lack of oxygen, scientists believe this may have been the case back on Earth billions of years ago as well. And prebiotic, or prior to actually living things, prebiotic chemistry happening on Titan cannot be reproduced in a laboratory on Earth. It's a real-time science experiment. Okay, so Titan is similar to Earth, but it's got some curious twists to it. Titan's terrain and landscape is similar to Earth with some interesting twists. So it resembles the Namibia in southern Africa in terms of terrain. It has sand dunes, but the sand is made of dark hydrocarbon grains resembling fine ground coffee. Those grains are methane and ethane. There are flowing rivers and lakes, some as large as the Great Lakes, and liquid methane, and of course has liquid methane instead of water, and temperatures well below zero at minus 291 degrees Fahrenheit. But there are clouds and rain, but they're made of methane instead of water. Okay. So with that in mind, what are the Dragonfly goals here? Well, first of all, is to measure the composition of materials at different geologic sites, determine how far prebiotic chemistry has progressed, look for pyrimidines, which are bases that are used to encode information in DNA, and amino acids, which of course are the building blocks of protein. Look for areas where liquid water may have interacted with organic compounds, investigate liquid methane on the surface, and analyze the atmosphere, which contains plentiful nitrogen and methane. Although Huygens did some sampling of Titan's atmosphere and surface, detecting tholins, and the surface composition really remains essentially unknown. It wasn't able to investigate that very much. And so they're hoping a Dragonfly is going to be able to really look at the surface and investigate that. So the Dragonfly spacecraft is essentially a large quadricopter with double rotors for redundancy. If one of the rotors stops operating, the other one will have enough lift to continue the mission. And including the 53-inch rotors, Dragonfly is 12.5 feet long 12.5 feet wide and about 5.5 feet high. So it's a pretty sizable spacecraft to be flying around. It weighs in at 1,900 pounds on Earth, but obviously on Titan, it weighs much less there because it's much lower gravity. So besides the quadricopter motor and control systems, the scientific payload includes the drill for acquisition of complex organics. Okay, that's the orange thing here in this diagram. And it's designed to extract, it's a rotary percussive drill to sample and pneumatically transfer surface material to the Dragonfly mass spectrometer, which is shown in brown here toward the front of the spacecraft there. Okay, and the mass spectrometer will identify chemical components, especially those relevant to biological processes in surface and atmospheric samples. Okay, in purple, down on the skids there of the Dragonfly, that's the gamma ray and neutron spectrometer. It consists of a pulse neutron generator and a set of gamma ray spectrometer and neutron spectrometers to identify the surface composition under the lander. In yellow, you'll see both on the skids as well as other places that those are all geophysics and meteorological package. And it's a suite of meteorological sensors, including a seismometer. Okay. The objects in blue there are the whole camera suite. It's a set of microscopic and panoramic cameras to image Titan's terrain and to scout for scientifically interesting landing spots. In addition, Dragonfly is to have multiple engineering and monitoring instruments to determine the characteristics of the Titan's interior and the atmosphere. And communication will be done directly with operations on Earth through NASA's Deep Sky network using a large gain antenna, a medium gain antenna, and a 100-watt traveling wave tube amplifier. All this is going to be powered by a 134 amp hour lithium ion battery that will be recharged when it lands and via the MMRTG, which I'll talk about in a second, which will also provide heat for the spacecraft.
Dave,
Zenobia
has a question.
Sure.
How much does Dragonfly cost?
Good question. And I don't know the answer to that question.
I'll do a quick Google on it.
I want you to Google that and let me know when you find out. So the MMRTG. So RTGs, radioisotope thermoelectric generators, are tried and true technology for NASA. They've been using them for years to provide power for deep space probes. Voyager, for instance, has an RTG that's been powering it for 45 years now. Okay, it's very simple. There's no moving parts. It consists of in the center where you see those pink or salmon colored boxes there. That's a 8 general purpose heat source. Okay, they are plutonium-238 dioxide that are contained in those boxes, and as that decays, it produces heat, and it'll produce about 2 kilowatts of thermal power. That heat passes through thermoelectric modules, okay, which are thermocouples that convert that heat to electricity, okay, and it'll produce about 125 watts of power at the beginning of the mission. That falls to about 100 watts of power after about 14 years, which I think is pretty curious since it's a 3.3-year mission, but okay. We have not only Voyager, but Perseverance and Curiosity on the Mars rovers that both have RTGs like this. Cassini had an RTG. So it's a very reliable way of providing electrical power. And there's going to be some residual heat from this that doesn't get converted to electricity. And that heat will be used to help keep the inside of the Dragonfly, help heat the inside of Dragonfly.
All right, okay, jump in with the cost.
Yeah, the cost is?
Sure. Yeah, the original cost at the time of inception in 2019 was $850, $850 million. Now the
Okay,
cost
so
is
wow.
Yeah, now the cost is $3.35 billion, and they're attributing
Wow.
that to some design changes, the impacts of COVID on labor and supply chains, and the need for a heavy lift launch vehicle. So
Right.
yeah, it's gone from 850 million to 3.35 billion dollars for the cost of the mission.
Yeah. I know that sounds like a lot, but I can almost guarantee you that there are a number of companies that are involved in this, and a lot of people, not just with NASA and ES and the European Space Agency, but a lot of companies with people who are employed doing this. So it's not just wasted money. It's paying people as well. So it's a good way of keeping people employed. Okay, so back to the mission. Launch date scheduled for July of 2028. It was originally going to be July of 2027, but it was postponed a year due to funding uncertainties. Read anything you want into that. It's going to be launched on a SpaceX Falcon Heavy. It's going to use an Earth gravity assist to maneuver and attain the necessary velocity to reach Titan. Total transit time from launch till it rendezvous with Titan is going to be about 10 years. Now, normally, deep space missions would use Jupiter for gravity assist because that's such a large gravitational well. But Jupiter just isn't going to be in a position that they're going to be able to use it as a gravity assist. So here's the trajectory of this. The time frame, everything here you can just move out 1 year, right? So uh, move to the right 1 year. Launch in June of 28 or thereabouts, June, July 28. It'll go out. It'll go out to about the middle of the asteroid belt, come back in, do a gravity assist past the Earth, which will then launch it out to Titan. Total transit time of about 10 years. Once it gets to Titan, it goes through an entry, descent, and landing phase. It's going to travel out to Titan uh, in a entry capsule that's attached to a cruising uh, stage. Okay, the cruise stage will communicate back with Earth. It will do any kind of mid-course corrections and things of that sort. The the uh, the Dragonfly spacecraft drone itself is going to be turned off. It won't even be on at all during the entire transit. Okay, they may turn it on from time to time to make sure systems are still operating, but for the most part, it's going to be idle. Okay, once the cruise stage reaches Titan, um, the cruise stage will separate from the entry capsule 10 minutes before encountering Titan's atmosphere. The lander would then descend to the surface of Titan using an aeroshell and a series of two parachutes, while the spent cruise stage would burn up in an uncontrolled atmospheric entry. The duration of the descent phase is expected to be about 105 minutes. Okay. Then at a speed of about a Mach 1.5, a drogue parachute deploys to slow the capsule to subsonic speeds. Due to Titan's comparatively thick atmosphere and low gravity, the drogue chute phase should last for about 80 minutes. Then the larger main parachute will deploy when the descent speed is sufficiently low, and that'll last about 20 minutes. During this phase, the heat shield will be jettisoned, and the landing skids will be extended, and sensors such as the radar and LiDAR will be activated. At an altitude of about 3/4 of a mile, the lander will be released from its parachute and perform a powered autonomous flight to the surface. All drone operations will be done autonomously because communication between Earth and Titan takes about 70 to 90 minutes in each direction. Okay. The target here is the Selk crater, which is about a 50-mile wide impact crater on the surface. The reason that they've chosen this is because an impact like that would have created enough heat to actually uh, create liquid water from the icy bedrock. Now, water would have frozen over pretty quickly, but liquid water would have been trapped beneath the insulating ice layer, including there's, one of the hydrocarbons on there is like ammonia is present, and if ammonia gets into the water as well, that acts as a natural antifreeze, and so the water could remain liquid for a lot longer. And then you blend water with organics, and an impactor's silicon, phosphorus, sulfur, and iron, and you get this primordial soup. So this is kind of a natural version of the origin of life experiments that have been run on Earth, except it's been running a lot longer. And Dragonfly is going to test that whole theory. And landing near Silk, it will fly from site to site, analyzing surface chemistry to investigate the frozen remains of what could have been prebiotic chemistry in action. Okay. So they think that because of the cold temperature, that this prebiotic chemistry would have been happening for a long time and never really resulted in the formation of life as we know it, because it's just too cold for that to happen. So let's be clear about this. Dragonfly is an mission to detect life. It's a mission to investigate the chemistry that came before biology here on Earth. Okay? On Earth, life has reshaped nearly everything, bearing its chemical forebear beneath tons of evolution, eons of evolution. Titan is an untouched chemical laboratory where all the ingredients for known life, the organics, the liquid water, and an energy source have interacted in the past. With a surface temperature of minus 291, 292 degrees, we don't expect to find life. Scientists have assumed that if a place has life's ingredients with enough time and complex chemistry, and eventually life should emerge. So Dragonfly is going to determine if that's true. You need to go from simple chemistry, complex chemistry to complex chemistry before jumping to biology. And that's what we're hoping to see on Titan is some of the simple and complex chemistry that preceded what we would consider to be life on Earth. And if Titan proves otherwise, if we look at everything and determine that no, that's not what's going on there, it may mean that we've misunderstood something about how life gets going, and we have to either rework the theory, and we may find out that life is actually a lot rarer than we thought. We think right now that life is probably pretty common throughout the universe, but of course we've never detected life anyplace else but on Earth. So we'll just this should answer a lot of questions for us in terms of what's needed to happen prior to the formation of life itself. So this is an exciting mission in many ways. The first test of this autonomous drone technology, which will really help to sample regions that are relatively far apart. Right now, we use these rovers on Mars, and they're great. We do a lot of analysis. They don't travel very fast, though. So, having a drone that's able to jump from site to site is going to allow us to take samples from geographically diverse areas and do some comparisons. We're exploring an environment that's not unlike Earth. It's just colder and it has a methane cycle instead of hydrologic cycle, but many of the components that we have on Earth are here on Titan as well. And then detecting the ingredients and the prebiotic chemical processes, of course, is the main thing here, and exploring theories about how life begins. Any questions?
Does anybody have a question for Dave? Dave, I must say this Dragonfly mission is like my favorite NASA mission. What this thing is going to do is going to be amazing.
It's pretty cool. Yeah, it's pretty cool.
I threw a couple of internet facts in the chat. It'll launch on a SpaceX Falcon Heavy rocket. It's expected to fly for 3.3 years and cover between 100 and 115 miles on Titan's surface. Multiple short flights of about 8 to 10 miles each between measurement stops. It's going to perform a flight every 16 days, which is Titan's orbital period around Saturn.
Right.
Let's see. Yeah, it's gonna explore 20 to 30 distinct geological sites, dunes, craters, etc.
Right.
And like you had mentioned, the nuclear powered RTG will charge batteries for 30-minute flights.
Right.
So I guess each flight's gonna be about 30 minutes. So this is basically gonna fly around like a drone. That's basically what a an amateur drone does, like
Yeah.
30-minute flights.
Right. Right.
It doesn't
Right.
say how high it'll go. Did you happen to run into that?
I didn't. I don't think I have that in here, but it'll fly high enough to be able to go over dunes and the lake. I mean, the atmosphere is pretty thick. It should be able to gain pretty good altitude doing that. So, but it doesn't need to fly high. It needs to fly far. So,
Oh, it says here Dragonfly will fly up to 13,000 feet during shorter
ah,
flights of Titan while covering total distances over 108 miles over multiple stops. The individual
ah,
flights are typically around
yeah,
5 miles long. 13,000 feet. My God. It's going to
well,
fly at about 22 miles an hour or so, up to 22 miles an
yeah,
hour.
they do want to be able to sample the atmosphere too. So I can see that. Okay,
This is just going to be amazing. Does anybody have
we're
any
going to learn
questions
a
for
lot.
Dave? Looks like we had 18 people on the call, Dave. Great,
Okay,
great presentation as always.